Hello all. Today let us discuss about median filtering and mean filtering. Let's also see about some problems related to the images. Let's talk about median filter as the first part. And you know that it's a high pass filter. So you will be using this to get the features, edges of an image. Compute the median value of the marked pixel using a 3x3 mask. So here this particular value 4 is being marked here, and they have given us a 3x3 mask. So you try to put a mask over this, okay, and try to arrange this in an ascending order, all the values of in an image in an ascending order. Try to find out the midpoint. So that midpoint should be replaced in the place of the center value, that's 4. So you have to replace 4 by 3. This is what the median for this, considering a 3x3 mask. Let us see about the next other mask where it's given as a window size with other form of an image. So apply median filtering for Y of M, that's let the image be 23842, and the window size they have given as 3 again, and it's -1 0 1 1. Okay, so you are going to apply window something like this here. So this two, the first one, the last two becomes the boundary value. Okay, so V of 0 and V of 2, V of 4 that's equal to 2 is going to be your boundary value, and it's also the boundary value. So the middle 4 values is be taken for the windowing function. So you have to apply the window for those values. So V of 1 when you apply, so you will get this 238 will be there, and try to arrange this in the ascending order and find the center point. So this is going to be 3. Similarly proceed. Next is 384, arrange in the order, so therefore it's 3 4 8 and just 4 around the middle one, so that's 4. 4 is going to be your answer. Here same, median of 842, arrange in ascending order, so it's 2 4 8, therefore 4 will be the center value, and so replacing by 4. So finally the answer is 2 3 4 4 and 2. Yes, this is the median filter when a window is given to you. So here it's -1 0 1 comma 2, it's an even window size. So you have a 4 window size sequence. Yes, now let's find the median values. V of 1 is going to be 3, and V of 2 is median of this 2 3 8 and 4. Yes, since you have 4 windows, you have to take the 4 values there. So when you take the first 4 values, you try to arrange that in the ascending order. Yes, and try to find out the middle value. Here the middle value is 3 and 4, since it's an even number. So try to add that and divide by 2. That's take an average for that. So that's 3.5. And again for similarly for the next term also you get 3.5 and so on. This is how you have to proceed when you have given with an even window. Yes, and always ensure it should be arranged in ascending order. Now I have given you 3x6. So here but the mask is given as 3x3 mask only. So we have to find out the median value for the place which has been marked here. We have to replace those values. So initially take a 3x3 mask. I have given it with a yellow color masking there, and within that yellow color mask try to arrange the elements in an ascending order and try to find out the center value 24 and replace that 128 with 24. Okay, try to move this mask to the next set of pixel values, again covering a 3x3 mask. So again arrange in ascending order and try to find out the middle value. So that's going to be something like 31. So replace this 24 with 31, and next again slide the mask to the right hand side, so that 33 25 32 this particular part of the image 3x3 image is being selected, and within that mask try to find all the values, arrange in ascending order and find the middle value, that's 31 here. So replace 172 with 31. Similarly try to move the mask again to the right hand side and keep finding it, and here is the value is same as 26, so keep it as such. So your solution will be try to replace those values with the values that what we have found by varying the mass to the right hand side as per the requirement. Yes, hope you understood the median filtering. Let's see about the mean filter. The mean filter is also called as a low pass filter, is also called as average filter. Yes, and here the mean filter replaces each pixel by the average of all the values in the local neighborhood pixels. This kind of spatial filter is also called as a box filter. Box filter, mean filter, average filter or low pass filter. And it could be sizes like 5 cross 5, 7 cross 7, 3 cross 3, 9 cross 9, goes like that. Let's see how a mask is being applied for this image. 3 cross 3 spatial mask is taken for an image of the values given here 1, 2, 3, 5, 4, 6 or something. Just now we have to replace the center value here and take all the values, sum it up and take an average, that's by 9 here, so you get 5. So try to replace 4 with 5. This is going to be your mean filtered output. Now I told you about that it's the other name for mean filter is a low pass filter. Let's see how it is it's behaving like a low pass filter. Let's take it in frequency domain. Okay, so 3 cross 3 mean filter let us take. So it's like 1 by 9, 1 by 9, 1 by 9 you have for entire 3 cross 3 matrix. Let me take 1 by 9 as common. So you have 1, 1, 1, 1, 1, 1 and 1, 1, 1. Okay. To represent that your signal, your image pixel components in terms of impulse delta functions using shifting properties, first let us explain this graph here. X axis be n1, y axis be n2, the center point be n1 comma n2 and the one to the right hand side be n1 plus 1 and the point to the left hand side be n1 minus 1 and the point above be n1 plus n2 plus 1 and the point that's below your center point be n2 minus 1. So using this you will be able to clearly find out the 9 points. Okay, so this point is your center point. So you have 1 by 9 delta of n1 comma n2. This is your first point what I have wrote here. The second point what I have written here is this point. So I have 1 by 9, okay, delta of n1 minus 1 and you have n2 is same n2 value, okay, n2 is remains the same here. And let's take this point as the third point what I have written here. It's 1 by 9 delta of n1 plus 1 comma n2 again. Got it right? So for all these values your n2 remains same. For all these row your n2 becomes n2 plus 1. Okay. So for all these column here you will have n1 minus 1. All these will be n1. All these column will be n1 plus 1. This row will be n2 minus 1. So using those you will be able to fill up all these 9 elements by using the impulse function and shifting property of impulse function. Let's take Z transform on both sides. So you will be getting 1 by 9, 1 by 9 Z inverse, and since you know that when you take Z transform for x of n, it's going to be x of z. Yes. So when you take Z transform for x of n minus 1, and you can say that it's delayed by 1 unit, so z power minus 1 into x of z. Yes. So by using this z power minus 1, so I get here x power minus 1, x power z power x1 and z2 minus 1, it goes like that. So by using the property of shifting in time domain. Yes. So you have similarly I am trying to find out the Z transform for all the 9 components, and there is a relationship between Z transform and DTFT, that is Z is equal to e power j omega. So, substitute Z everywhere with e power j omega and try to rearrange very comfortably and try to group your e power minus j omega 1 plus e power j omega 1, so that you are trying to express in terms of cos theta, okay. You know that e power j theta plus e power minus j theta by 2 is your cos theta. So, in that way you should be comfortable in writing it. So, I am just doing the small changes and trying to bring my answer as 1 by 9 and DC constant plus as coefficient 2 by 9 into cos omega cos term. Similarly, I am trying to replace everywhere with cos terms with the corresponding coefficients values. Yes. So, my final answer is going to be 1 by 9 plus 2 by 9 cos omega 1 plus 2 by 9 cos omega 2 plus 4 by 9. So, 2 cos terms here, cos omega 1 and cos omega 2. Now, you have been asked to prove it's behaving like a low pass filter. So, let us try finding it by substituting few values for omega. Let us take a case 1 where I am substituting omega 1 and omega 2 as 0 here. So, when I substitute 0 there, and its cos 0 is 1, here also cos 0 is 1. So, I get adding up all the coefficients alone, which is summing up to 9 by 9 and the answer is 1. So, your DC component is 1, here is 1 by 9 and finally, your answer is 1 for x of 0 comma 0. Similarly, let us try for 2 more cases. First case let me take it as omega 1 is equal to pi by 2. And third case let me take it as omega and omega 2 is equal to pi. So, when I substitute that and find, I will be getting as 1 by 9 for the case where it is pi by 2 and I will be getting still 1 by 9 the same for the case pi. So, when I plot it in a one dimensional graph, I will be getting 0 to 1 here and it will be, there will be a drop here at pi by 2, it is 1 by 9 and again it is being continued. This is a perfect low pass filter. Yes. And when you take it as a 2D graph, you can just plot it, and in the 3x3 mask you will be able to find something like a hexagon hat, and a low pass filter is being understood from the frequency responses. Yes, and thank you.